Let's do one more example from section 4.4, which again is L'Hopital's rule. We're asked to find the limit as x approaches infinity of x plus 2 over x minus 1 raised to the power x. So let's think about what situation we have. It's actually an indeterminate power. We have indeterminate form 1 to infinity. Now, keep in mind that L'Hopital's rule, somehow we have to get it into a form 0 over 0 or infinity over infinity. Right? So, we have to do some algebra first. The limit as x approaches infinity of. Now I'm going to let you fill in the steps here. X plus 2 over x minus 1 is the same as 1 plus 3 over x minus 1. So we have 1 plus 3 over x minus 1 raised to the power x. Okay? Now, what I'm going to remind you of is again, this is more algebra. A to the b is the same as e to the b ln a. You've probably seen that before. Maybe you have just forgotten it because it's been a while. So we're going to use that in this situation. Okay? So I have now, again, so far all I've done is algebra, no calculus yet. So this is a limit as x approaches infinity of, what, using this result right here. Okay? I have e to the b, in this case, is x. ln a, which in this case is 1 plus 3 over x minus 1. So originally what we had was indeterminate form 1 to infinity. Now I've used properties of the exponential function. So look at our exponent right here. As x goes to infinity, what I actually have is an infinity times 0 situation in the exponent. So things are improving a little bit. What I can do now is rewrite this. What I want is for the exponent to be hopefully a 0 over 0 situation. So what I can do is I can rewrite this as e to the natural log of 1 plus 3 over x minus 1 all over 1 over x. All I'm saying is that x is the same thing as 1 over x. So what we have here is this. We have e to the 0 over 0. 0 over 0, of course, is indeterminate. So I'm passing the limit operation into the exponent. Okay? So, again, up to this point, it's really just been algebra. And at this moment, I'm going to actually use L'Hopital's rule. So I had the limit as x goes to infinity of e to the, well, now what I have to do is I have to differentiate the numerator and the denominator. The denominator is easy. The derivative of 1 over x is negative 1 over x squared. Now, the derivative of the natural log of 1 plus 3 over x minus 1. I'm going to use the chain rule. So I have 1 over 1 plus 3 over x minus 1. And then I'm going to multiply that by the derivative of the inside, right? It's a chain rule. So I have negative 3 over x minus 1 squared. So notice that these negative signs are going to cancel, okay? So what I'm going to have is the following thing. I'm going to move on to the next piece of paper. Again, we have the limit as x goes to infinity of e to the 1 over 1 plus 3 over x minus 1 times negative 3 over x minus 1, the quantity squared. All of this is over negative 1 over x squared. So I have e to the 1 over 1 plus 3 over x minus 1 times see if I divide by 1 over x squared, that's like having an x squared in the numerator, so I have 3x squared over x minus 1 squared. So we're going to keep in mind x is going to infinity, right? So 3 over x minus 1, that's going to go to 0, isn't it? And then this limit right here, right, what we have is a rational function with the degrees of the numerator and the denominator are the same, and both leading coefficients are equal to 1. So this limit right here is just going to be 1 when I pass this limit operation in. So what I'm left with here is e cubed, or e just raised to the 3rd power. So that is our limit. Our limit is e cubed. Now, could we have predicted that from an earlier point in the problem? And the answer is yes. Okay? If we go back to this point, right, okay, what you have to keep in mind, and this is helpful, okay, you think of e to the r as being the limit as n goes to infinity of 1 plus r over n to the n. Okay, that is helpful.